Hello and welcome to Maths by SAS. This is my fifth lesson of D2 chapter number 6 exercise 6a, that is about algebraic fractions. In this lesson I will solve intermediate level question number 5 that says simplify each of the following. Before going to the lesson, there are some key terms that we have to understand, that we should have the good hold on multiplication and Devian law of indices with same basis, and types of factorization and basic algebraic identities, and integration of lesson with the previous lesson for the better and clear understanding of the lesson. Let's move to the first part of the question. Question is 9x into a minus b whole square upon 27 into x cube into a minus b whole cube. If we look at the question is having some constant coefficients and some variable terms. For the constants, like for 27, table of 9 is suitable for 3 times. 9 ones are and 9 threes are 27. Now for the constant coefficients, I will left with 1 over 3. If we look at x and x cube, we are having the like terms, same terms of x in the numerator and denominator with different parts. So what I have to do in order to solve x terms, I have to apply the Devian law of indices with same basis, and according to that I have to write the base ones and subtract the indices. As a larger index is 3, which is in the denominator, so I will bring the smaller index, that is 1, so it will become x3 minus 1 and it will become x square. Looking at a minus b whole square upon a minus b whole cube, take it as a single term. Again we can see that a minus b has the larger power in the denominator, so again I will be applying the Devian law of indices with same basis, and it will become a minus b raised to power of 3 minus 2, which is 1. So my answer will be 1 over 3 into x square and a minus b. I hope you are clear about this question. Left to B part of the question. B part of the question is 7a cube into a minus 3b whole 4 upon 21a square b into a minus 3b whole square. It's always good to rewrite the question, so I've written the question for you. If you look at the constant coefficients 7 and 21, table of 7 is suitable for 21, so 7 ones are 7 and 7 threes are 21. So from the constant coefficients I'm left with 1 over 3. Looking and checking the a terms, a cube upon a square. Here a have the same basis with different parts. So in the numerator and denominator we will apply the quotient law of indices with same basis, and I will bring the smaller index towards the bigger index. So a3 minus 2 will give me a1 or a only, and coming to a into 3b minus whole 4 upon a minus 3b whole square. Take a minus 3b as the same base and the single base. Here again we have to apply the quotient law of indices with same basis. So what I will be doing, I will write a minus 3b, 4 minus 2 will give me 2, and upon b. So the final answer will be a into a minus 3b whole square upon 3b. I hope this question is clear to you. Question, that is 8a into b cube into 2a plus 3b whole square upon 32 into a square b multiplied by 3b plus 2a. Rewrite the question, and if we look at the bracket, in the numerator bracket is having 2a term first and 3b terms later, so it's better to rearrange the bracket which is in the denominator. So what I will be doing, I have to write it 8 by 32 a into b cube into 2a plus 3b whole square, and in the denominator I will write a square b and rearrange the bracket 2a plus 3b. Now if we look at the constant coefficients, we can see Table of 8 is suitable for 32. 8 ones are and 8 fours are 32. So in the next step, what I will be doing, from the constant coefficients, I will left with 1 over 4. If we look at a and a square, they are the terms with the same base with different power. So here we have to apply the division law of indices with same basis, and I have to bring the smaller part towards the larger part. So it will become in the denominator, and a2 minus 1 will be a only. Checking the b terms, we have b cube upon b. B has the larger part in the numerator. So what we will be doing, we will be bringing the smaller part in the numerator, and it will become b3 minus 2 b square. And coming to the last part of the question, that is 2a plus 3b whole square, 2a plus 3b whole square upon 2a plus 3b. Again 2a plus 3b, take it as a single term, and it has the smaller part in the denominator. Bring it up and write it 2a plus 3b. 2 minus 1 will be 1. So my answer will be b square into 2a plus 3b upon 4a. I hope you are clear about this question. Let's move to the next question. The next question is 8 into a n cube into b plus c upon 96 a square n into c plus b whole square. Rewrite the question and think about that for 96 table of 8 is suitable. How many times? 8 12s are 8 1s are and 8 12s are 96. So from the constant coefficients, I will left with 1 over 12. Checking the a terms, I have a upon a square. A has the larger part in the denominator, so apply the quotient law of indices. Write the base ones and subtract the indices. 2 minus 1 will be 1. So I will write just a. Looking at n terms, n cube upon n. Then I have the larger power of n in the numerator. I have to apply the quotient law of indices with same basis. It will become n3 minus 2 n square. And coming to b plus c term, b plus c upon c plus b whole square. C plus b and b plus c are same terms. So we can write it b plus c 2 minus 1, and that will be 1. So my final answer will be n square upon 12a into b plus c. I hope you are clear about this question. For next difficulty level, please catch me in the next class. Watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.